Okay, so let's review our code from the part 1 of LinkedList from scratch. So we created a node class, and it just stored some string data, but we could have stored anything in there we liked. We could have stored integers, strings, employees, whole arrays of employees, and so on. We could have stored anything we liked. Okay, any sort of data we like, any structure. But we're just storing simple strings. So just a name, and then we've got two referential class objects here. One's the next node, and it's of type node, so it's self-referential class we're using here, and the pry node. Okay, so we've got two node objects here, one for the next node in the linked list, and one for the pry node in the linked list. A default constructor just calls our parameterized constructor and passes through a name of double quote, or blank name. Here's our parameterized constructor, and when we create a node, we set the next node to null and the first node and the pry node to null as well, and just store the string there. We've got some accessor methods, or an accessor method getName, and then a mutator method that sets the name to the value passed in. Set next node sets the next node to the node passed in, and a get next node is an accessor method, and then a mutator method set pry node, and it sets the pry node to the node passed in, and a get pry node. So that was our node class, just a nice simple little class. We're not doing any validation, we're not doing any verification, we're just keeping the code as simple as we can. Okay, so that's our node class. And then we had a linked list from scratch tester class or driver class, where we created some node objects, set the next node and pry node links, and then traverse the linked lists forwards and backwards. Okay, now this code here, we can improve it a lot, because if anyone wants to use our node class, they've got to do the plumbing manually. Okay, so we want to make that a lot easier. First thing I might do is I might rename these nodes, because node 1, node 2, node 3 is pretty awkward when you're adding them in different orders. So I might call this moose node, and we'll have a Bella node. Take off the 1, 2, 3s, and then we've got a Frankie node. You can do this as well if you like, follow along, because I'm going to go through the linked list and build it with these new node objects shortly, and we'll have a look what's actually built. So we're just going to do a full revision plus a lot more. And if you don't like that, you can skip ahead. Okay, if you've already got a good handle on linked list, you can skip ahead if you want to, but so here's our Hank node. Okay, so there's our node objects being created. So each one of these node objects has got a string plus the next node and a pry node. Okay, so it's all the data that's up here. Every node gets its own copy of this data. Okay, so we might just fix our plumbing down here. So Moose node's next node is Bella. Bella's node's next node was Hank, I think. I had it like that, Hank. Hank's next node was Frankie. Frankie's node next node was Samuel. That's the sort of setup I had. Okay, so Moose node went to Bella node went to Hank node went to Frankie node went to Samuel node. That's the way I had things linked. You can link them any way you like. It doesn't really matter. Okay, just to redo the same sort of thing here. Bella node's pry node was Moose. Hank's pry node was Bella. Samuel's pry node was Hank. And Samuel's pry node was Frankie. Okay, so that's the sort of setup we had. Okay, and what you can do if you like is you can move these so they're close to each other. So you can set up the forwards and backwards if you want to. Okay, so Moose's next node is Bella. Bella's pry node is Moose. So we're setting up the linkages both ways. Bella's next node is Hank, and Hank's pry node is Bella. And of course, I'm very fussy about the spacing of my code. I love nice, neat code. Hank's next node is Frankie. Frankie's next node is Hank, and so on. If we're going to draw a diagram and see what it's like on a diagram, which is a great way to go, we can do that. Okay, so here's our Moose node. and it's got a string of moose, and we're setting Moose's next node to Bella and Bella's prior node to Moose. So we're putting in these linkages here. So Moose's next node is Bella and Bella's prior node is Moose. Okay, so we're putting that forward arrow and that back arrow, all the linkages forward and back. And then we've got Bella's next node is Hank and Hank's prior node is Bella. Okay, so Bella's next node is Hank and Hank's prior node is Bella. So next node and prior node. Hank's next node is Frankie and Frankie's prior node is Hank. So Hank's next node is Frankie and Frankie's prior node is Hank. And then we've got Frankie's next node is Samuel and Samuel's prior node is Frankie. Okay, so Frankie's next node is Samuel and Samuel's prior node is Frankie. That should say Frankie. Okay, so I didn't quite have it finished. Okay, so that's Frankie node there, not node 3. And we've got the first node is Moose and the last node is Samuel. So that's our linked list set up there. Okay, so that's all that code does. We've walked through it now again. And so when we traverse the linked list, if we want to start with Moose, we can set current node equal to Moose, while current node is not equal to null. Print out the name of the current node and go to the next node, and keep looping while we're not equal to null. In other words, until we haven't got to the next node that's got a value of null. And going backwards through the linked list, we start off with Samuel because Samuel's our last node, and while current node is not equal to null, get the name of the node and display it, and then move back to the prior node of the linked list. So we're stepping backwards through the linked list. So all okay so far. Hopefully that's pretty well explained for you. If you like, maybe watch the video again and think about this diagram. Okay, so we're just putting in the linkages between the nodes. Okay, so how can we improve this code? Well, we could create a linked list class and actually have it do the plumbing automatically. So it sets up the next node and the prior node, and that's what we're going to do now. Okay. So what we'll do is we'll just comment out this code for now, and we're going to reuse it, but make it more generic. So I'm just commenting out this code for now. That's in our main program there. And I'm going to create another linked list class, or another class called linked list. I'll keep everything in the same file for now, so it's much easier to change and review rather than flipping between tabs. So I'll keep it all in the same file, but we could move these out to their own files and make them into their own linked list class, linkedlist.java and node.java and so on. That would be quite okay and good thing to do, but we'll keep it all in one file for now. Okay, so a linked list is made up of a class which has a first node, so private node first node, and private node last node. And that's really all the linked list has to keep track of. Okay, and when we create a new linked list, so this is our constructor, we could just initialize both of those to null. They will be anyway by default. Equals null. So we're creating our linked list. Let's just make sure everything's null. They will be anyway because Java takes care of it. But anyway, it's not a bad idea to do it and keep everything initialized, because we might add more in here later to keep track of things. For example, the node count and so on. Okay, so let's now add a method called add public. And we could make it a Boolean method if we wanted to return true if everything was okay. We could just make it a void method. We'll make it a void method for now. Void add node. I'll call it addNode, and we'll pass in a string called name. Okay, so add a node. What do we want to happen here? So if we go to our little diagram, when we start off with a linked list, everything's just empty. So first node and last node point to null. Okay. When we add a first node, after we've added a first node, we should have a node with a name of whatever, and first node and last node should both point to that new node that we just created. Okay, so it's just one node in the linked list, and both our nodes should point to that. So what we're going to do in our addNode here is if first node is equal to null, then we're going to create a new node, and we're going to pass through the name that we've passed in. So we've created a node, and we're going to point first node and last node to that node. Okay, so that's the code we've written. It's just the same as this code here. So we've created a new node with the name of Moose, and first node and last node both point to that node, or both refer to that node. Okay, and that's just what we've done. Now if first node's not null, we need to do something different. So there's going to be an else here, but we'll think about that in a second. Okay. So now what we should be able to do is down here in our main program, we should be able to create a linked list class. Equals new linked list. So I created a new class object called linked list, and we should be able to go dot add node moose. Okay, and that should add our first node to the linked list. We can't see it yet because we haven't got any method to display our linked list node object yet, so we could add that in as well, and it's very similar to the code we've already written. Public void forward traversal. I'll call it forwardTraversal. You can call it whatever you like. But we're going to go through our linked list forward, and it's pretty well just this code here. So I'm going to copy that code from down there and paste it up there in our forwardTraversal. So it's just the forwardTraversal code we've already written, except instead of starting at Moose node, we're going to start at first node. So that's all I've changed. I've copied and pasted that forwardTraversal code, and that is all I've changed. Okay, so we're starting at the first node in the linked list, and we're going through until we find something that points to null. And then we've run out of nodes. Okay, so I should be able to call that now down here. Linked list, so linked list object forwardTraversal. All the other code in our mains commented out, as I showed you earlier. I haven't uncommented anything. That's what our mains become. So we've created another class, and we're moving the complexity up into this other class, and we're making it so it's so easy to work with linked lists. Okay, so let's run that. Control 1, Control 2, and there's our code running. forwardTraversal, and we see Moose on the screen, which is what we expected. Okay, just one node, and it's got a value of Moose. Now, what happens if we add another node to the linked list? Okay, so this is what we've got. We want to add a second node. And this is what we want to end up with. So we want next node pointing to the new node, and that new node referring back to the prior node. And first node should still point to the first node that was originally added to the linked list, and last node should point to the new node we've just added. Okay, so what we want to do is traverse our linked list until we find a node that's pointing to null, a next node that's got a value of null, and add a new node in there. Okay, so we've got a little bit of code to write. It's very similar to this sort of code here. We'll grab that forwardTraversal code. So I'm just highlighting those lines and copying them, and I'm going to paste them up inside our else statement up here. Okay. We still want to create a new node. Okay, so creating a new node there with the name that was passed in, and so we want to get to current nodes. As soon as current node points to null, we're not going to traverse any further. Okay, so while current node's not equal to null, so when we end this loop here, current node should be pointing to null. In other words, we're at the end of the linked list. So what we want to do is point last node equal to the new node. And what we want to do is, so this is going to keep looping until current node is equal to null. So by the time we get to null, we've gone past the last node. So we want to stop when we get to the last node. And the last node is the one where the current node dot get next node is not equal to null. Okay, so you want to keep looping until current node get next node is not equal to null anymore. In other words, go through all our nodes until we get to the last one that's pointing to null, and that's what current node will have the value of. Okay, so that'll be our current last node, and what we want to do is say current node dot set next node, which is calling one of our node class methods, to the node that we just created, our new node, and we also want to do the prior plumbing as well. So node dot set prior node to our current node. Okay. So that's one way to do it. There's another way as well. I'll show you shortly. Okay. And so let's now test that out and see how we go. So let's add another node. We'll add Bella, and we'll control 1, control 2, and there's our Moose and Bella. So everything's working great. Okay, but we can actually simplify this code a lot, because this is really just moving us to last node. Okay, so we can actually streamline this code a lot by saying node current node equals last node, and we could actually take out all that code. So you don't need to loop through it all, because our last node is currently our last node in our linked list. So we could make that the current node, set last node equal to the new node I just created, and then set the current node's next node to the new node we just created as well, and set our new node prior node to what is our current node. Okay, so we're just fixing up the plumbing, pointing new node across the new last node, and fixing up the plumbing between our prior last node and our new current last node. Okay, so if we have a look at our diagram there, you can see it a lot clearer. So originally last node was pointing here, so now last node's pointing there. Our old last node's next node is now our new node, and our new node's last node is our prior last node. Okay, so current node's just keeping track of our last node. Maybe I could call it something better. Original last node, or prior last node, or something. Current last node, why not? Current last node. Okay, so that makes it a bit clearer for you. So current last node is the current value of our last node. Last node now points to our new node. Our current last node's next node is now our new node, and our node's prior node is our current last node, whatever that was. Okay, that should be fine too. So let's run that and compile it. So we don't need to use a loop at all, and it's working great. Let's add another linked list, or another node to our list, and we'll add Hank. So we've got 3 nodes. Moose, Bella, Hank. So everything's working great. And you can see working with linked lists is now a lot simpler. We just declare a linked list object and go addNode, and it fixes up all the plumbing for us, which is terrific. Let's now add in, so that takes care of all this code. So our code now does this automatically, so we can forget about that. We've got the forwardTraversal in, that's working great. Let's now add the backwardTraversal as well. So it's our last little bit of code we had from before, and we can make it so our linked list class does it automatically for us. And I'll call this one backwardTraversal, backwardTraversal, whatever you want to call it. And it doesn't start with a Samuel node, it starts with the last node. Okay, this last node object here. So it starts at the far end of the list and works backwards, get prior node. Okay, so that's the only thing I had to change. So with the forwardTraversal, the only thing I had to change was from Moose to first node to make it so it work with any linked list objects, linked list class objects. And when going backwards, we start with our last node. So that used to say Samuel node. That's all I've changed. Okay, so we should be able to do a backwardTraversal as well now. So we'll do a forwards traversal, then we'll do a backwards traversal. Make sure everything's linked up properly. Oh, 5 errors. Node current node. So I've got to declare current node. I didn't do it below because these are all part of the same scope. Control 1. So I said to put that node in there as well to declare node, the current node. Control 2, and there we are. So we've got the forwards traversal, Moose Bella Hank, and the backwards traversal, Hank Bella Moose. So how easy is it to work with linked lists now? It's dead easy. Okay, and that's basically what the linked list class in Java does. It provides these methods, or methods like these, maybe called different names. So what if you want to add a new node into the middle of a linked list? Or somewhere in the middle, or somewhere after the first node and somewhere before the first node. So if you want to add a new node. So this is your situation before, maybe, with just 2 nodes, just assuming 2 nodes. And this is your situation after. So you want to fix up all these linkages here. So you want to create a new node. At the position you want to add the new node, you want to make it so that prior node or that current node points to the new node, and that new node's prior node is that node you're adding in between. And what was the next node is now the next node for this new node, and that prior node for that what was the next node is now our new node. Okay, so we want to fix up all the linkages. A good analogy to think of here is, well, the one I think of is like bulldog clamps and battery terminals. And I've got batteries all linked together with bulldog clamps, and I'm unclipping the positives and hooking it onto the negative. I'm unhooking the negative and hooking it onto the new positive, so that everything joins together in series properly or parallel properly, whatever you want to do. So think of bulldog clamps, and you've got to attach them on and fix up all the linkages. So we'll write the code to do this now. And we won't assume that that node's a Moose node and that node's a Bella node. We'll make it so we can add a node anywhere in our linked list. Okay. Before we do that, we might just add a count node to count the number of linked list nodes in our linked list. So we'll do that first, and then we'll add the code to add a new linked list somewhere in the middle. Okay, so we'll have a count as well. Private int count or size, whatever you want to call it. Make it count's fine. And at the start, count is equal to 0. And when we add a new node, we go count plus plus. And when we add a new node down here, we go count plus plus. Okay, so we're keeping our count up to date as we add new nodes to the linked list. And maybe we'll display the number of nodes here in our, when we traverse, plus count, plus count, plus nodes. So we'll say forward traversal 5 nodes or whatever as we forward traverse. We'll do the same thing on the backwards traversal as well. So we're traversing whatever nodes, 5 nodes or 1 node or whatever. And we must add a size method as well, so we can get the size, public int. If you want to call it getCount, that's fine. Or if you want to call it getSize or whatever, that's fine as well. Probably should keep the same name. If you call this the number of nodes count, then you should be getCount. And that's just going to return the count. So if anything outside of the class needs it, it can get the count as well. Righto, so let's now, might as well run that and test it so you can see the counts working. And there we go, 3 nodes and 3 nodes. And I need a bit of a space in there, 3 nodes. That's all working fine. Traversal, put a space in there, so it's backwards. It's coming out with a space. Okay, so let's now add a method to. So it's going to be like our addNode method. Okay, it's going to be like that, but we're going to pass in an integer as well. So we can add a node at a certain location. addNode int index or location index, whatever you want to call it, and a name. So we've now got 2 addNode methods. One just takes a string, and one takes an integer and a string. Index lowercase. Okay, so if index is equal to 0, then we're just adding a first node. Really? Adding a new first node. Else, if index is less than count. Okay, so don't forget our nodes start at 0 index, just like arrays do in Java and everything else does in Java. So our first node is index 0, and our last node is count -1. So if index is less than count -1, we can add it somewhere in the list. Else we can't add it. If index is less than 0 or our index is greater than or equal to count, we can't add it. So we may display an error message, system.out.println. Of the list. Cannot add a node outside of the list. Something like that, whatever makes sense to you. Okay. So if index is 0, we're adding a new first node. So what we want to do is create our node, same code as up here, and then we want to link first node to that new node. But what if our linked list is empty? Okay, and so we'll add this in as well. And if first node is equal to null, then we just want to do that same code. Okay, so maybe we'll take that down to the else. So first node's null and index is 0. We're adding our first node at the first location, which is the only place we can add it. And so it's just this code here we want to run. So why don't we just call that addNode method to save duplicating code. addNode name. Okay, so that'll call this code up here. First node's null, it'll add the node into the right location, update count, and away we go. Okay. Otherwise, if first node's not equal to null, we're now going to be running this code. So we'll keep a backup of our current first node equals first node. Just for a second, so we can fix up our battery linkages, and our new first node is equal to node, our new node that we just created. Our node's next node, so set next node, is our current first node. So we're linking up the linkages all again. And our current nodes and our current first nodes. So what was the first node's now the second node? That's prior node is our current node. So current first node dot set prior node to our newly created node. So we're just fixing up the linkages as we go, and I'll just neaten this code up a little bit. Okay, so we're keeping a backup of our current first node, setting first node equal to our new node that we just created, setting the next node to our new node to the current first node. What was our current first node is now our second node, and setting up our linkages back to the prior node. So our current first node, which is now our second node's prior node, is our new node. Okay, so we're just fixing up the linkages, and that should be it. That should be all we need to do. So we can now add a node in the middle of our linked list. Okay, if index is less than count and not 0, we need to write some code in here. So what we're going to do here is traverse our linked list until we get to the right node, and then we'll run much the same sort of code as here. Okay, fix up the linkages. Except we won't be working with first node, we'll be working with current node. Okay, for this special case where we're adding a new node somewhere in the middle of an existing linked list, which has got more than no nodes. Okay, so we want to create the new node, same code as up here. Create the new node, add one onto count, and now we want to position this node in our linked list. So we want to position it at a certain location according to index. So we want to set node, current node is equal to first node. So we're just going to traverse our linked list starting at the first node. We'll have a counter as well. Int node count is equal to 0 while node count is less than index, the location we want to insert the new node. We're going to just keep moving between nodes. So current node is equal to current node dot get next node, and we'll add one onto node count. So if we want to insert at index location 3 in our linked list, then we count for that many nodes to get to the right place in our linked list. So when we get there, current node is where we want to insert the new node. So from current node, between current node and current node's next node, that's where we want to insert our new node. So we can do that. So we'll keep track of node current next node is equal to the current node's get next node. Okay, so current next node is our current next node. And so what we're going to do for our new node, we've created up here, we want to make node.set next node to our existing current node with a semicolon on the end, and we want to set current node's set prior node to our current node. Node, not mode, node. Okay, so if we have a look at our diagram, I can show you the linkages we're adding. So what we've done is we've created our new node. That's this line of code here, creates our new node. We've traversed our linked list to get to the right location, and current next node is this node. We're assuming we've got more than, not necessarily Moose and Bella, it could be anywhere in our linked list of many nodes. So this is our current next node, and we're saying node's next node is our current next node. So we're creating that little link there between our new node and our existing current next node. And we're saying current next node's prior node is our new node. So current next node's prior node is the new node we just created. So we're just putting in those linkages there. So all these linkages here are done now between this node and our current next node. Now we need to link in first node to our new node. So cur node dot set next node to our new node, and node, our prior node to our new node, set prior node is our current node. So we just inserted these two linkages here. So current node's next node is now our new node, current's node and next node is our new node, and our new node's prior node is our current node. Node's prior node is our current node. Okay. And if you're like me and you like everything lined up, you've got to do that. I can't sleep unless it's done right. And that should be it. So let's just check our code, create a new node, loop until we get to the right place, create the linkages between the existing next node and our new node, and then set up the linkages between our current node and our next node as well. Just so we're doing everything in the right place. I might move that count plus just down to the end, because we've done it last in every other location, so I'll just move that down to the end there, so that so I don't actually forget that I've added it up the top here. So we should be able to add a new node now. Let's just test our code. So what we'll do is we'll Frankie. So we'll add a new node at location 0. So 0 means this new node should be inserted at the front of the list. So the new linked list should be Frank, Moose, Bella, Hank. And that's what we see. Frank, Moose, Bella, Hank. And then backwards, Hank, Bella, Moose, Frankie. So our forwards and backwards is working right. All our linkages are correct. Let's now add Frankie at location 1. So our linked list should be Moose, Frankie, Bella, Hank. Okay, let's compile and run. And that's what we see. Moose, Bella. Oops. So I just had to make that node count 1 there. So we're starting at the first node, so node count should be 1. We're already at the first node, and we're checking what's after it. Okay, so let's run that. So we got, let's insert it 1 here. So it should be Moose, Frankie, Bella, Hank. Moose, Frankie, Bella, Hank. Hank, Bella, Frankie, Moose. So forwards and backwards is correct. Let's add another location 2. So it should be Moose, Bella, Frankie, Hank. Moose, Bella, Frankie, Hank, Hank, Frankie, Bella, Moose. So it's it's correct backwards and forwards. Okay, so you should be feeling pretty comfortable, hopefully, or at least starting to feel less frightened of linked lists by now. Let's add one last method in and we'll add a removeNode method. And for the removeNode method, we're going to remove a node that's indexed by integer. So public void remove node int index. So it's going to be similar sort of code to what we had above. We're going to loop to the right location in our linked list, and then fix up our linkages after we remove that the required node. So if count is equal to 0, so if count 0, then we want to put out an error, system.out.println something like that. So linked list is empty, cannot remove a node. If count's 0, there's no point looking at what index is. We can't remove that node. You could also say if index is less than 0 or index is greater than or equal to count. Then you could say cannot remove a outside of linked list. Okay, so the index is less than 0 or it's greater than or equal to count. So we're assuming everything starts at 0. So count's the number of nodes and indexes. So if count's 5, index locations or valid index locations are 0 to 4. Like an array in Java, just the same thing. So if it's less than 0 or it's greater than or equal to count, we're outside of our linked list. And else, now we can do the actual removal. So what we need to do is similar sort of code to what we had above. We want to count the nodes and loop through them until we get to the right location, until we get to the node we want to replace, and then we want to fix up our linkages. Okay, so it's similar sort of code to what we had above. So we might even grab that code there. So I'll grab that code. And what we could do to test, if you like, is we could display the value of that current node. System.out.println current node dot get name. So we're getting the name associated with that node. Okay, just as a bit of a test to the screen here. So so we'll loop to the right location and make sure we are getting the right node by saying current node get name. Okay, and then we'll write the code to actually delete the node down here. So we've still got code to write, but we're just doing a test to make sure we're in the right location. So with this code here, we're actually we want 0 to mean the first node. We're deleting the first node, not inserting a node after the first node or whatever. So I'm thinking we want that count to start at 0, but we'll do some testing anyway, make sure. Up here we could have started at 0 as well, if we made that maybe a less than or equal to, or whatever. There's many ways to do these things. Okay, but here we're looping and actually going to delete the node that we nominate. 0 is the first node, and 1's the second, and so on. So remove node, let's say remove node 0, and we should have moose. Let's remove node, and remove node 1. It should say Bella. So Bella, that's all looking good. Remove node 2 should say Hank, and remove node 4 should say not a node in the linked list or something like that. Cannot remove a node outside the linked list. Okay, and same with -1 or 0, -1. Cannot remove a node outside the linked list. So everything looks like it's working right. It's finding the right node, and so now let's go and write the code to actually delete the node. So it's all about fixing up the linkages again. So it's going to be similar sort of code to what we've got above here. Back to this sort of code again. You find yourself writing this same sort of code a lot. So this is when we're adding a node at a certain location. I might just copy that code there and paste it down below, and we'll scavenge it. Okay, so here's where we want to write our code to actually delete it. So, so we want to delete the current node. Okay, which means if there is a prior node, we want that prior node's next node to be current node's next node. Okay, so maybe we want a prior node, get prior node. Okay, so current prior node. I'm not worried about node anymore. So the current prior node's next node will be the current node's dot get next node. Okay, so the prior node is one before the current one, and if that's not null, just to take into account when we're deleting the first node, then the current node's set next node is equal to the current node's next node, whatever our current node next node currently is. Whatever its next node is now our current node's, our prior node's next node. Okay, and so that's setting up the forward linkages. Okay, now you want to set up the backward linkages. So if current node get next node is not equal to null, in other words, they're not at the end of the list, then we want to fix up the linkages backwards, back to our current prior node. And so here I might just make our code a little bit simpler. Rather than calling get next node all the time, I might add that up here as an object. Current next node is equal to current node get next node, and use current next node there, and use current next node there. Okay, so we've got a current prior node is our current node's prior node, and our current next node is our current node's next node. So we're getting the ones either side, and we're going to use those to eliminate the current node. So if current prior node is not null, then current prior node's next node is our current next node. And if current next node is not null, then our current next node's prior node is our current prior node. And because I've done that simplification with naming the stuff above, I don't need that extra bit. And we want to go count minus minus, so we're removing a node. I think that's correct. Keep track of the prior node and the next node to our current node. If the prior node's not null, fix up the linkages to our next node. And if the next node's not null, set up the linkages to our prior node, and then remove one node from our linked list. I think that's correct. Okay, looks pretty good to me. Okay, so when we remove node 0, we should see just Bella and Hank on the screen. Don't forget your semicolons. So removing the first node, which is node 0. So we should, Moose is gone. We should just see Bella and Hank. Moose, Bella, Hank, and Bella, Hank. So we forgot something there. Did you pick what we forgot? It's fixing up our first node and our last nodes. So if first node is equal to our current node, so first node's our current node, then we want to fix up first node. So first node is equal to our current next node. So we're deleting our first node, and our first node is really our current next node. And we also want to do that thing here. If last node is equal to our current next node. Well, actually, if last node is equal to our current node, then we want to say last node is now our current prior node. So we're just fixing up our last nodes and our next nodes as well. So first node, if our current node is our first node, then our new first node is our next node. And if our last node is our current node, then our new last node, or our last node from now on, is our current prior node. So that's correct. So we fix up those as well. Okay, so that's the code I've just added in there to make sure our linked list is still correct after we've created nodes and so on. In fact, we want to have similar code here with fixing up our nodes as well. So if our index count's 0, oh no, we take care of that here. Index is 0. No, that's all right. I think we're okay. Okay. So you can see your code gets fairly complex pretty fast because there's so many things you can do with deleting and inserting nodes. But the great news is you only have to write the code once. And once you understand a linked list work from scratch, you could even use Java's built-in linked list. So let's just review what we're going to do. So we're removing the first node. So we should see Bella and Hank. Control 2. Bella and Hank. Hank, Bella, reversal. That's all correct. Let's remove the second node, which is index 1. So we should see Moose and Hank, and then Hank and Moose if reverse. Moose and Hank and Moose. And let's remove our existing last node, which is Hank, and we should see Moose and Bella and Moose. Moose and Bella, Moose. And if we try and move something outside the list, like node 3, which doesn't exist, we should see that error. Cannot remove a node. So everything's working great. So it's all a matter of keeping your linkages right, making sure first node's pointing to the true first node, making sure last node's pointing to the real last node. And when you insert nodes, fix up your linkages. When you remove a node, fix up the linkages. And that's it. So the great news is you only have to write this code once. And in fact, you could even make this node class here a generic class by making that less than t greater than, or actually just t. And calling that something else other than name, object or whatever. No, not object, because object's a reserved word. And making it a generic class and so on. So if you want to see how to do that, you could look at the generic classes video I've got there in my webpage. We'll just leave it as a string for now. Okay, but you could make it so this stored any type of data by making that a generic, and so on. Wherever there's a string, change it to a generic data type. And same here, make those generics. Wherever you've got string, make it a generic data type, and there and so on. And you'll make it so your code can work with any type of data: employees, products, arrays of products, linked lists of other objects, whatever you want to store. And that's basically all we're going to cover for this video. So a quick recap. We've got our node class here. Nothing's changed in this video. We haven't changed anything in our node class. We've added a linked list class. We've got first node and last node to keep track of the beginning and end of our linked list. A count to keep track of the number of nodes. Default constructor initializes everything. An addNode method to add a node at the end of our linked list. An addNode at a specific index location. So addNode 0 inserts it at the start of our list. addNode 1 inserts after the existing first node if there is one, and so on. And then a forwardTraversal, backwardTraversal. That was the same code we had previously. We just had to change that to first node, not Moose node, and we had to change that to last node, not Samuel node, or whatever it was. A getCount, a removeNode loops through our linked list and removes a particular node and fixes up our linkages. It also keeps track of our first node and last node, make sure they're correct as well. And that's basically it. So we've removed a mountain of code. All this code's commented out, plus a whole lot more we've added. And now our linked list is really easy to work with. It's just declare a linked list object, add nodes, as many as you like, and then remove nodes, whatever node you like, and then forwardTraversal, backwardTraversal, whatever you want to do. So pretty easy to work with once you've created it. So if you're comfortable with that, then you're ready to work with linked lists in Java. You can use the built-in class now because you understand how it all works. So hopefully that's removed the fear that you might have had, if you had any fear of working with linked lists. They're really quite easy. Once you've written a couple of linked lists, they're very easy to write. Or if you understand things reasonably well, you're now ready to start using a linked list class in Java. I reckon it's always better to do these things at least once from first principles before you start making use of classes you don't really understand, so that you know what's going on. You know what's going on behind the scenes. Anyway, I hope that was useful. Thanks for watching.